You built an app. Maybe you prompted your way through with ChatGPT, or you followed the tutorial. Either way, it works on your laptop. Congrats. So now what? Platforms like Vercel and Lovable let you deploy with one click. That's fine for side projects, but if you want to understand what's actually happening when you click that button, or debug when it breaks, or get hired at a company that doesn't use buttons, you need to understand Docker. This is Docker from first principles. By the end, you'll understand containers, images, Dockerfiles, and where Docker fits in the stack. No fluff. Let's go. Here's why it works on my machine is the most expensive sentence in software. You write code on your laptop, you test it, it works perfectly. Then you deploy it to a server and it breaks. Why? Because your laptop and server are different. Different operating systems, different versions of Node or Python, different dependencies installed, different environment variables altogether. The code is the same, but everything around it is different. This is where teams lose hours, days, and sometimes weeks debugging things that aren't even code problems, they're environment problems. The issue isn't your code, it's that you're only shipping your code. You're not shipping everything your code needs to run. So what if there was a way to ship your environment, not just your code? What if you could ship your entire machine? Instead of deploying just your code and hoping the server has the right setup, you package everything together. Your code, your dependencies, your configs, your runtime, everything your app needs to run, bundled into one package. Now the environment itself becomes the thing you deploy, not just the code. And here's the key. Same package runs anywhere. Your laptop, a server, the cloud, it doesn't matter. Same package, same behavior. That package is called a container. What is a container, you might be asking? A container is a box that holds everything your app needs to run. Nothing more, nothing less. Think of it as an isolated environment for your application. It has its own file system. The container sees its own files, not the host files. It has its own network. The container gets its own port and IP. It has its own processes. What runs in the container stays in the container. Containers can't see each other. They can't affect each other. They're isolated. But here's what makes them powerful. They start in seconds, they use minimal resources, and they run the same everywhere. You build a container on your laptop, you run it on a server, same behavior, and that's the promise. But wait, this sounds like a virtual machine, so what are the differences? VMs are houses and containers are apartments. A virtual machine is like a house. It has its own foundation, its own plumbing, its own everything. Each VM runs a full operating system, and that's heavy. Gigabytes of overhead, minutes to boot up. A container is like an apartment. Apartments share the building's foundation, plumbing, electricity, but each unit is separate. You have your own space, your own keys, your own stuff. Containers share the host operating system's kernel. They don't need their own OS. That makes them light. Megabytes and not gigabytes. Seconds to start and not minutes. Same isolation, fraction of the overhead. Here's the stack. VM hardware, then hypervisor, then a full guest OS, then your app. Containers, on the other hand, you need hardware, then host OS, then Docker, then your app. Way fewer layers, way more efficient and simple. So how do you create a container? Well, you start with an image. An image is a blueprint. A container is the building. An image is a read-only template. It defines what goes into a container. It contains the base operating system, your dependencies, your code, and the command to start your app. Once you build an image, it never changes. It's immutable. And that's important. It means you can trust that the same image always produces the same container. One image can create unlimited containers. They'll all be identical. Think of it like a recipe versus a cooked meal. The recipe is the image. You can make as many meals as you want from the same recipe. Each meal is a container. Or blueprints and buildings. One blueprint and many buildings. One image, many containers. But where does the image come from? You write a Dockerfile. A Dockerfile is the recipe for your containers. 5 lines can define your entire environment. A Dockerfile is just a text file. It lives on your project right next to your code. It's a step-by-step instructions for building your image. Each line is one layer. Let me walk you through a simple one. So the first line from Node 18, that starts with the base image. So for this one, Node.js already comes installed. Workdir app, that sets your working directory inside of the container. And copy ... that copies your code into the container. And when you run npm install, that will install your dependencies. And command node server.js, that command will run the container when it starts. That's it, 5 lines. And you've defined your entire environment. You run docker build, it creates an image from these instructions. Every time you build, you get the same image. Reproducible. Now you have an image. Where do you put it so servers can access it? A registry is like a GitHub, but for container images. You've built an image on your laptop, but your server needs to run it. So how does the server get the image? That's what a registry is for. It's a central storage for images. You push your images from your machine to the registry. Any server can pull images from that registry. Docker Hub is one of the biggest public registries. It's like GitHub for containers, free for public images. Companies use private registries like AWS ECR, Google GCR, GitHub Container Registry. Same concept, but it's private. The workflow is that you build locally, you push to that registry, and the server pulls it and runs it. One push, deploy anywhere. So now you understand the full picture. But here's one thing Docker doesn't really solve. Docker solves one problem. Here's what it doesn't solve. Docker gives you packaging, its consistency, isolation, your app runs the same everywhere. That's huge. But what happens when you need more? What if you have 10 or even 100 containers? How do you manage all of them? What if a container crashes? Who will restart those crashed containers? What if you need to spread traffic across multiple containers? Load balancing? How do you handle that? What if you want to update your app without downtime? How do you perform rolling deployment? Docker doesn't do any of that. Docker runs the containers, but Docker doesn't manage the containers at scale. That's a different problem. And that's where Kubernetes comes in. Think of it this way. Docker packages your app in a container. Kubernetes runs and manages those containers at scale. Docker is the shipping container. Kubernetes is the shipping yard. You need Docker before you need Kubernetes. That's why we started here. And that's Docker from first principles. Let's recap what you learned. So the problem was that it works on my machine, but it breaks in production because the environments are different. So the solution is that you'll package your environment, not just your code. And that's a container. Containers are isolated, lightweight, and run the same everywhere. Images are blueprints for containers. Dockerfiles are recipes for images. Registries store images so servers can pull them. And Docker is just packaging. Kubernetes is what runs containers at scale. In the next video, we'll be talking about Kubernetes from first principles, how to actually run and manage containers in production environment. If you want that, subscribe. I'm putting out technical content every week. Stuff that helps you go from I built it to I shipped it. See you in the next one.